All right, so far this unit in systems of equations, we have learned to solve systems using two methods. The first was graphing, the second was elimination. Today we're going to learn the last one, which is substitution. The big idea with substitution is that you want to get a variable by itself or solve a variable. When you get one variable by itself, you're going to substitute what it equals into the other equation. Remember that all systems of equations have a solution that's an ordered pair. We also talked about the other two types of solutions. You could have no solution or infinite solutions. To get started with substitution, I'm just going to kind of review how to solve a problem like this. If I ask you to evaluate 3x plus 4y equals 1 when x equals -2, you're just going to take this x value and plug it in place of x. So this would give us 3 times -2 plus 4y equals 1. So 3 times -2 is -6. Then I have my plus 4y equals 1. And that's where I'm going to add 6 to both sides. And then I know all of you are going to freak out when you see this, but to completely get y by itself, I divide by 4, and I end up with a fraction of 7/4. We're going to use this exact same idea and use it with two equations and two variables instead of one equation and then a variable that equals a number. So our example is solve the following system using substitution. I have -3x plus 2y equals -2, and then I have x equals -4y plus 24. Notice that this x here is already by itself. So I'm going to take what it equals, and I'm going to put it in place of my other x. So just like in the problem where I put a number in place of a variable, I can also take another expression and put it in place of that variable. So in place of this x, I'm going to write what x equals, which is -4y plus 24. And then I'm going to continue on with the rest of the equation. Plus 2y equals -2. And from here, I can just solve like normal. So I need to distribute this -3 first. So this will be 12y minus 72 plus 2y equals -2. When you notice in this step, as soon as I simplify this, when I substitute it in for x, now I have one equation with only one type of variable. So from here, I just combine like terms. I need to get y by itself, so I add 72 to both sides. And then I divide by 14. And 70 divided by 14 is 5. So I have that my y value is 5. Remember, in systems of equations, you can't just have one value. I have to solve for x and for y. Oh, that's freaky. Okay. I don't know why the y equals 5 is traveling up with this. So what I'm going to do is I'm going to take this y equals 5 and put it back into my original equation of x equals -4y plus 24. So this is the original equation I started with. I'm going to take, again, what y equals and substitute it in for y. So I get x equals -4 times 5 plus 24, which will leave me with x equals -20 plus 24. So x equals 4. So my answer is the ordered pair 4, 5. That first example took a lot of the page. We're going to look at the second example. It's very similar. In the first example, as you noticed, x was already by itself. I had a variable that had nothing else around it. In this problem, I have an issue because I have a 3y and 2x, and I also have a 2x and a y. Although nothing's completely by itself, I do notice that this y doesn't have any numbers in front of it. So to get it by itself, all I have to do is subtract 2x from both sides. So I'm going to continue this work over here. I have y equals 9 minus 2x. So now that I have what y equals 9 minus 2x, I'm going to take 9 minus 2x and put it in place of y in my other equation. So I have 3 times 9 minus 2x minus 2x equals 11. Again, here I have a distribution problem, and then I'm just going to solve for my variable. So this would be 27 minus 6x minus 2x equals 11. I'm going to combine my like terms so that I am left with 27 minus 8x equals 11. Now to get x by itself, I subtract 27 from both sides. And I am left with negative 8x equals negative 16. So last but not least, to get x by itself, I divide both sides by negative 8, and I have x equals 2. Once I have my x value, I use that to find the y value. So I use my substitution again, and this time I'm going to substitute 2 in place of that variable of x. So I have y equals 9 minus 2 times 2. So y equals 9 minus 4, which gives me y equals 5. So these two linear lines would cross at the point 2, 5. They both have that 1 point in common. So after seeing those two examples, I want you to try this one on your own. As you can see, it is slightly different than the other ones you've seen. But what I do notice here is that I have this y almost completely by itself. I only have to do one thing to get rid of that 3. So I would start there, get y by itself, and then you have to substitute that into the other equation. Good luck!